This is the 2-for-1 rule, how to accelerate the flow and reduce WIP with the 2-for-1 rule. Off we go. I'm Philip Marris. I live in Paris, France. I'm bicultural, French and English. I started my operational excellence journey with Lean, in fact, back in 1984. A little bit later, I met Elio Goldratt, the founder of Theory of Constraints. So I've basically been combining those two things, plus Agile, plus Six Sigma, plus common sense and whatever, in mostly industry, over 385 times right now, around the world, half in France, half in the rest of the world. I'm the author of a very boring book about applying the theory of constraints in manufacturing. I founded Marris Consulting 20 years ago. We were kind of hard to describe where we work. It's where physical products are, but the physical product can be a bicycle, a motorbike, a car, a train, a plane, a rocket, pharmaceuticals, dog food, lampposts, tanks, and all sorts of other stuff in here. You can see from there. Quite a lot of work in luxury goods, Swiss watches, Louis Vuitton, and stuff like that. So this is, we're very curious and we love to go from one kind of business to another. That's where we are, mostly in physical goods, a little bit in services. There are 15 consultants and our network of partners, more than 500 videos on our YouTube channel. We do about 40 sessions like this every year. Have a look at what we do. The 2-for-1 rule. Well, I've been basically reducing or trying to reduce the inventory in organizations ever since I left university, right? In my first job and then when later on as consultants. It's always been a bit of a battle, or at least more painful and slow than I would have liked. So this is about something I discovered 17 years ago, which I've been using ever since. And it's in fact very powerful, very simple. And it's how we reduce inventory now. What's significant is that everybody wants to do this, whether you're in the lean approach or any other, a Kanban system, a one-piece flow, a con whip, a drum buffer rope, whatever. You're always trying to synchronize work by stopping work. And so the interesting thing is how you intelligently stop people working in the right place at the right time to synchronize activity. And if you do that properly, you're going to be better at delivering on time, improving the quality, improving your agility, freeing up your cash flow, and facilitating your process of ongoing improvement, right? So it's all win, 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 win. You must always try and reduce your inventory. So back in 2008, 17 years ago, one of our assignments in a middle of nowhere, French factory making drawn steel pipes, asked us to help them. They've had problems with delivering their customers on time. Their lead times were too long. They were feeding the automotive industry that was very demanding in terms of OTIF and lead times. And they were missing everything and they were losing business and it was getting to be kind of desperate. We did a diagnostic. We looked at how we could change the parameters and the batch sizes in the ERP. We did some education and stuff, but it just wasn't happening, at least not happening fast enough. And so I remember I was with my number two in my company, Selim, and we were sitting there thinking, how can we do this, right? That's when we had this idea, this innovation. I don't know if we invented it first or if other people invented it before. There had to be more tubes or more stuff that left the factory that was coming than that was coming in. Okay, this 2-for-1 rule that happened then. Very, very simple. More must come out of your factory or your system than what's going in, right? 2-for-1. So this factory, you can see the pictures there. In fact, as it's 17 years ago, people weren't taking that many pictures in dark factories at the time before the smartphones became so good at making pictures and stuff. So I don't have pictures of how the factory was before. You couldn't see the machines at all. There were pipes everywhere, and pipes just take up a lot of room, right? They quickly take up a lot of space. And in this factory, it was awful. There were pipes everywhere. You couldn't see the machines, you couldn't see the people. It was chaos. They had bad delivery performance, a big backlog, a lot of silos between departments, between workshops and stuff. Everybody was trying to keep their machines busy. It was just madness. We'd done a quick diagnostic of the flow. The two machines that were bottlenecks were both non-destructive testing machines and not the core business. If you're interested in that kind of thing, have a look at the other videos we have on finding bottlenecks and what kind of bottlenecks we find. It's not that surprising that non-destructive testing should be the bottleneck. That's what it was. And we launched some work which had two work streams. One which was improving the constraint performance, right, the bottleneck performance, and the other one which was to reduce inventory using the 2-for-1 rule. This was just the first time we used it. And as a result, the inventory shrank from 4,000 tons to 2,000 tons. On-time delivery went from 53% up to 92%, and then a bit later 98%, and again a few years later 99.5%. Anyway, that problem was solved. And delivery volumes and productivity increased by 45%. I'll be talking about that quite a lot, because the crazy thing is how much you get improvements in efficiency, overall productivity, output, if you reduce the work in progress. So what can I say? I mean, if it's been so hard for us for all these years, and if I still today go into factories and they have 2 times or 4 times too much inventory, it's because people are not very good at this, are they? Even though Toyota's shown us the way for decades now, we're still not very good at repeating it in our industry. Why do people have that inventory? Well, they say that it's because of the variability, the breakdowns, the absenteeism, and whatever. I believe, and I'll be coming back to this on several occasions, that it is also quite a lot, if not mostly, to do with the fact that you want to try and keep everybody busy. And therefore, to feed them, you start launching stuff into the system to keep people busy. And that is why you end up with so much inventory. When you do that, well, you get very, very, very long lead times. You get chaos because there are so many work orders going on, so many priorities that everybody's changing priorities every hour, every minute, or whatever. So it goes completely mad. You can't manage quality. You can't solve a problem because the lead times of everything are so significant, right? When you find a quality problem, it was produced on another machine 3 weeks before because of the internal lead times are so bad, right? In project environments, because this rule applies both to projects and to production, it leads to bad multitasking, and that leads to a significant drop in efficiency, in quality. Triggers making mistakes and stuff. Here are some pictures. Just you can't actually see the machines anymore, can you? Most of the time, there's so much inventory. You know, the LIFO, last in, first out, and therefore first in, last out. Right. This stuff here at the bottom, those are inventory labels. So that's been there 8 years, 9 years, and stuff piled up all over the place. There seems to be no limit. Well, the limit is usually either there's not enough space left to put it in, but where are the machines? I mean, this is just inventory. These are not warehouses. These are factories you're looking at. So this simple rule of 2 for 1 makes you increase the flow. It improves the service rate. You'll see this with the examples. It significantly reduces the lead time, and it improves the overall productivity. I'll come back to that several times because that's counterintuitive. Maybe throughput goes up as you reduce inventory. How do you implement the 2 for 1 rule, right? You want 2 items to go out of the system for every item going in, right? You want more stuff going out than going in. The first thing to do is to choose the unit with which you will work. In production, we usually work with work orders, and in projects, we usually use projects, the number of projects in your portfolio. There can be other solutions. I have used it a couple of times with other units, like the number of parts or pieces, the number of pallets, the number of containers, the number of tons, the number of liters. So there can be variance. And then you need to work out what kind of environment you're in, because, of course, it's different depending on how long your lead times are initially and how many units you have, how many work orders, for instance, you have in your system, right? If you have a 9-month inventory and you apply this rule for 9 months, right, your 9 months of work is going to go out of the system, but only 4.5 months is going to go into the system. So you've got 4.5 months of inventory, and therefore you've reduced your inventory and your lead times by 2. You'll divide your WIP and lead times by 2 once per average lead time. Okay. If your lead times are very short, watch out. This is going to be very quick and very violent. If your lead times are already quite long at the beginning, it's going to take you a while. You can't do anything about that. That's just physical. The system has to empty out. At the same time, you work on the performance of the bottleneck. That's our clear constraints message. You don't actually have to do that, but frankly, nobody I know does that without finding the bottlenecks and trying to produce more. And as a result, by the way, that means that you're sort of more like producing twice as much and only launching as much as you used to, right? That's the better way of playing the 2 for 1 rule. You'll see this with the examples. When you're doing this, watch out, please. It's crazy how some companies have dead work in progress. So we're only talking about the live work in progress when we're doing the calculation and estimate of what's going to happen to the system. This is from a very reputable company. What you see here, what's in dark blue are rocks right there. And then you can see from the inventory with 1, with 2, with 3, with 4, with 5. For work in progress you cannot sell. It's got quality problems. It's waiting for decisions, whatever. The only stuff that's flowing is the live inventory. Watch out if you have a lot of dead or immobile inventory in the system. That should not be taken into account when you're trying to work out how this rule is going to impact you, because that stuff is not going to move, is it? This is all about having a common sense manual rule that takes control of your flow, and only afterwards do you explain to your ERP what you've done. You don't use your ERP to reduce your lead times or your work in progress. You reduce your work in progress, and then you explain what you've done to your ERP system, right? This has lots of virtuous properties when you do it this way. When you do this, right, you apply the rule. Imagine you're in manufacturing, and your MRP system will therefore propose that a certain number of work orders should be launched into the factory, but you are only allowed to launch a certain amount defined by the 2-for-1 rule, right? So imagine that in that week you finished and completed 10 work orders, right? The ERP system will probably propose that you launch a new set of 10 work orders, and you're only allowed to put 5 of them into the factory. So you're going to have a look at those 10 work orders and try and work out which ones are the most intelligent, the most pertinent, right? And this is where the fun starts, because you'll start seeing that, unfortunately, like in many factories that we meet, you don't actually understand what your MRP system is suggesting and why. And it is suggesting things that you asked it to do, but which are no longer relevant. It's asking you to produce big batches of stuff. It's asking you to add more batches of work you've already got several batches of, because they're all blocked by non-conformities or quality decisions and stuff. So it's a fascinating step where you start trying to work out why the ERP is suggesting that you launch all this stuff. And that's when you start to choose the best or the least bad of the suggestions of the MRP system, and you put aside the others. Therefore, choke the system manually. Don't change anything to the MRP system initially. By the way, this will force people to try and close properly the work orders, because quite often people are pretty lazy about actually closing properly the work order. That's because there's a part missing or something hasn't been done. And so even though they're not working on it anymore, the work order is still in the system, right? Well, you're going to have to work out why that is and properly close up all the work orders. Otherwise, you're not allowed to launch any new stuff into the system. They're very important. If you work this way, you're actually going to try and understand what the MRP system is doing, and you're going to take back control, because you'll find that a lot of that stuff is just bad, too big batches, incorrect volumes of inventory as targets and stuff, right? So this will be very interesting. As you go down the system, by the way, you'll reduce the conflicts, the priority conflicts. We usually start with a diagnostic of a factory or a project system, and we usually find on average that there are 6 concurrent, simultaneous priority systems, right? The one of the boss, the one of the commercial guy, the engineering guy, whatever. There's so many different priority systems. Basically, everything is a priority for somebody, and as a result, the people don't actually worry too much about what the priorities are, right? There's so many possible. And that's because there's so much going on, so many work orders. It encourages this, doesn't it? And so as you reduce the inventory, you're reducing the conflicts, reducing these crazy, useless discussions about which work order you should work on next. It also forces skill versatility or multi-skilling. It forces people to go from one workstation to another, because think about it, you're actually going to only launch half as much as what you used to in the gating operations at the beginning of your process, right? So they're going to have to finish their work after 4 hours in an 8-hour shift, right? They're going to be fed only 50% of what they used to be fed. So they're going to go to their boss and say, what do we do now? And normally the boss should say, well, why don't you go down to the end of the process and help them so that we can produce more? This is one of the reasons why you'll see the spectacular increases in throughput and output of the factories when we're applying the 2-for-1 rule, since we're asking people who used to work in the gating operations to go down to the process and try and help at the end operations to get more out the door. Have a look, for instance, at the SKF client testimonial, because that was a beautiful case where the people who the quality control down at the end of the process was the bottleneck, and the machining people had excess capacity. They were no longer being fed, so they went down to quality control and started helping with the quality control. And that's when they discovered that they were the cause. Anyway, there will be 50% workload at the beginning of the process, right? And rather than going, I don't have enough work, tell these people, go down and help out, right? That's going to get more out the door. If you get more out the door, the 2-for-1 rule will enable you to get more in the door because of the 2-for-1. When we do this, you have to be very careful to ensure that there's proper communication. And so whatever, into your daily meetings, your plenary sessions with all your town halls or whatever, you have to announce this and say what you're going to do, because otherwise people are going to get worried about what's going on, destabilized and so forth, right? This is not just the production people, not just the supply chain people, but human resources, purchasing, sales administration and so forth. Everybody's going to be involved. If you apply this rule, you're not going to be consuming so much going into the factory, and therefore you're going to be ordering less raw materials, right? You need to discuss with purchasing and procurement what you're going to do about that and what impact that's going to have and make sure that that doesn't destabilize people so much. Sales administration, I'll come to it in a second. If you're doing this in an environment where you're already delivering late, your on-time delivery is not good, you have a backlog and stuff, do not tell your clients you're going to do this, right? Because they're not going to understand. They're going to worry. You're saying that you're late, and you decide to stop launching stuff into your factory. So watch out. Don't tell your clients that you're doing this. They won't understand. Don't tell your old-fashioned vice presidents either, because they won't understand, right? Communicate with everybody, but watch out what you tell people at the customer end of things, because they might worry that if you're not putting stuff into the factory, the backlog is going to increase. You'll see that, in fact, the opposite happens. As I say, that volumes increase and we catch the backlog. Okay, so this has got to be announced clearly to everybody, so that everybody understands what's going on. Normally, if you do it properly, it shouldn't be a big problem, right? A 10-year-old child can understand what we're trying to do, right? More stuff going out than what's going in because there's too much inside. That doesn't mean necessarily that you stop taking orders or choke the whole system. We'll have a look at in the examples in a second about in an oil and gas gear manufacturer, they had too much inventory. They applied this rule. They continued taking in the orders. Right? They just didn't start working on them, or rather they faked working on them. They did the first sort of 5% of the work and said, okay, yeah, we started. And then they stopped so that the system could empty properly. The same in a luxury luggage manufacturer. You saw who we worked with, so you can guess who. And we ensured that they had a full kit of information before they started their work. And that slowed down the launching initially into the system and led to having a full kit and therefore much faster when they got started. A major player of fast food, that's McDonald's. We did a huge work. I mean, they're big, right? They had a system where they measured the time it took between the client order and the moment the kitchen started working on the client order. The logic being the faster I start on the client order, the faster I'm going to be finished. Since I'm a fast food, that's the way to do it. We stopped that and we ensured that they only launched new orders into the kitchen when the kitchen was ready, right? So the kitchen, in fact, pulled the orders into the kitchen to avoid chaos. And that improved the flow, improved the quality, improved the productivity also, right? So it happens everywhere. This is universal truth. You can continue taking orders like McDonald's do, like this oil and gas company did, okay? You just don't take the stuff into the system, right? You just say, thank you very much, we've got the order, and you then start on it when the system is ready to do it. Let's have a look at some examples. This one here is Safran, which is a large original equipment manufacturer in aeronautics. We launched the 2-for-1 process in their 400-person factory that was basically going to close because they were so late. Everybody was screaming at each other. It wasn't working at all. So we applied the 2-for-1 rule. As you can see here, the units there are not work orders. They're parts, number of parts in the system. They have 1,032 work orders when they started. They applied the 2-for-1 rule based on work orders. And as you can see, the inventory just went down significantly at the beginning. And by the way, they were so impressed at the beginning, they were basically doing 4-for-1. Let's just say 4 work orders out for 1 in, because the MRP was suggesting such crazy work orders that they decided they wouldn't launch half of them. They would only launch a quarter of them because they couldn't work out why the system was proposing so much crazy stuff. Right. Anyway, they did this for quite a while. Then they reduced their inventory by a factor of 2 down here in the middle. And they said, okay, that's good. We beat our objectives. We're good, and so forth. And they lived like that for a few months. And then they said, hey, well, in fact, we rather like this, having less inventory. And they turned the system back on again and went further down, back down to reduced again by a half, right? As you can see from this, when we do this, we don't just do the 2-for-1 rule, right? It's an enabler to do many other improvements. And you can see here, there were changes made to subcontractors, changes to batch sizes, changes to organization. We stopped the overtime. We changed the setup times. So we did some SMEDs. So there's a lot of other stuff going on here, right? But the backbone, the guiding was based on the 2-for-1 rule that was enabling all this. In pictures, right, this is what it was like before. By the way, once again, the quality department was the bottleneck. Shelves are very bad for your health, aren't they? Because you want to put things on them. Anyway, this had the effect of going from 9 months to 2 months, and a bit later, by the way, one of their products doing their products in 48 hours, starting from 9 months, going down to about 48 hours for some products. They increased productivity by 30% in just 2 weeks, right? Because they just had to improve the performance of the quality control department of 15 people, which they did. And so 37%, I think it was, increase in throughput and output of the 400-person factory in just a couple of weeks. That's also caught their backlog and got their on-time delivery performance back up to first 95 and then 99. There's lots and lots of videos telling the story. Have a look at our YouTube channel. There's that one and many others. Here is in writing what the operations director wrote about all this a bit later when thinking back. In my experience, even in a desperate situation where overdue orders pile up, the bottleneck is no longer visible and poor managerial and logistical decisions have accumulated, deciding to switch to a system of one launch for two materials is a lifesaver. It allowed us to reduce the work in progress by a factor of 5, increase the flow rate. The RP system, which used to say it took 6 months to produce something, was able to produce in 4 to 5 weeks. And it had huge unexpected side effects. The scrap rate here was 12% when we started, down to 5% not even 2 years later. There was no big drive on quality. It's just that, you can't do proper quality when you're drowning in work in progress. So that's what he's saying, right? Better handle on quality, improve quality, reduce scrap, and all sorts of other good stuff. Second one is a subsidiary of Siemens, making big, expensive gearboxes that go between a generator and a gas turbine, that sort of thing, in power stations. Make to order, engineering to order, make to order. Big machines costing 50,000 to 500,000. 90 projects in progress, 50-week lead times, low productivity, nearly dying because they were in a down cycle of oil and gas. They decided to implement the theory of constraints and the critical chain. To get things started, we applied the 2-for-1 rule in the bottleneck engineering department. So you can see inventory shoot down here. What's happening there, by the way, that when I say you don't need to stop taking orders in, the order intake is the green stuff, right? The output of the design office, which was the bottleneck, is the blue stuff, right? When they turn on the rule, by the way, that means that they had to work on stuff that was already in the system, right? So they flushed out the system, and it was 1.8 finished designs per week initially. They went up to, as you can see, sort of 5, 6, 7 a week for a while as they were flushing out the system, and then settled on something where they were doing about 3 times more, because it reduced significantly the bad multitasking. Here's another example of factories in France producing aluminium extrusion for all sorts of appliances. We applied the 2-for-1 rule. That increased the on-time delivery from 85 to 99%, enabled them to launch a 24-hour service, 24 hours between an order and a delivery, divided by 3 of the lead times, and got to be the best in the market in terms of due date performance. TDK, Malaga, Spain. This one's fun because I hope it will just convince you how easy it is, because this happened during the pandemic, COVID. And so we did the training, the explanation online because we couldn't travel, and they did it all on their own. And it worked significantly. They were facing a huge increase in demand, right? So they ramped up significantly. And while ramping up, they didn't increase their work in progress as they might have. They reduced their work in progress and their lead times while ramping up very significantly and improving the customer service and all these things. And there's a client testimonial by Freddie, if you want to have his view of it. Nuclear valve manufacturer. Again, surge in demand because of power plants in China and the rest of the world. Had a lot of work in progress, 1,200 work orders, long manufacturing lead times, they were late, only 20% OTIF, significant customer dissatisfaction. We applied the 2-for-1 rule. There was quite a lot of existing work orders that were blocked for quality reasons or for client decision reasons and all these sorts of things. An adjustment of MRP parameters, cleaning up of the system. Shift to one operator on multiple machines, just yet another little mention as I go of how and why we don't just apply 2-for-1, right? We do other stuff. Work in progress reduction 50%, 1,000 more than 50%. OTIF, which was very bad, improved significantly, although it's still perfectible, and stabilized flow and a change in mindset of everybody. Another aeronautical equipment manufacturer producing actuators, again bad OTIF, backlog. Once again, same 2 actions. We reduce the work in progress by the 2-for-1 rule, and we find the bottleneck and break it or exploit it better, open it up. As a result, the productivity increased, the work in progress dropped by 78%, and they lived happily ever after. So those are some examples. When you do this, right, one of the important things to think about is how and when you're going to stop it. right? Because obviously you have to stop it one day. When do you stop this rule, right? You started, it's going really well, you reduce your inventory by 40%, by 70%, by whatever. When do you stop it? I'm born and bred theory of constraints, so my answer is the following. It depends on what's going on. And you do not stop when somebody charges into your office saying, hey, I don't have any work left on my machine. There's not a single work order. I can't do anything, whatever. You've got to do something. If you're a non-bottleneck, that's just normal, right? You can't work all the time on a non-bottleneck. You have to learn to stop working. What is important is to keep the flow through the system. So you actually only stop when there's a risk of the bottleneck being starved, right? A lot of people are going to stop working for lack of work. They're all the non-constraints. That's perfectly normal, right? But you only need to stop this rule and stabilize the level of work in progress when you start risking the bottleneck being starved. Level of utilization of a non-bottleneck resource is not determined by its own potential, but by some other constraint in the system. That's Eddie Goldratt at the time when I joined him in Creative Output, 1986, the rules of opt at the time. So how do you turn it off once you decided turning it off? You can just turn it off and go to new rules. I'll show that in the next page. Or you can do it gradually, right? You started off with 2 for 1, which is quite violent. You can go to 4 to 3 and then 10 for 9, right? I slowly tune down the system to get finally to a 1 for 1 system, right? Quite often we find people decide to not finish it brutally and turn it off, but slowly change the proportions 2 to 1, 4 to 3, 10 to 9 until they feel comfortable with what they've got. After you turn it off, what do you have? Well, you can just maintain the status quo by having a 1 for 1 rule. A 1 for 1 rule is also known as CON-WIP, constant WIP. That's been a solution known for many years. You can do that. Or you can start managing your flow through, for instance, drum buffer rope, Kanban, or some other kind of full system, or whatever, right? Other things you can be doing from there on is things like reducing the size of your batches. You can stay in the 1 for 1 system, but the batches going out are larger than the batches going in, so you continue reducing the inventory. And also normally, if you're applying, for instance, the theory of constraints, you start looking at the holes in your buffers in your system so that you can continue to improve and so forth. But you must ensure that you continue the pressure to reduce inventory because you always have too much inventory, right? Here we are. To conclude, the logic is so simple that a 10-year-old kid can do it, right? The only thing you really need is courage because it's scary, right? Especially for most people who start this thing, as you can see from my examples. They're doing it for a reason. They're doing it because they have too much. And if they have too much, it's probably already started damaging their performance. And so they're not delivering all their clients on time. And their lead times are a bit long, right? And if you're not delivering your clients on time and your lead times are long, stop launching things into your system when you're running late. Well, it takes courage, right? What's happening? Well, you have to learn to stop working. It's still a big problem for many people. They don't realize that whether it's Toyota and Kanban and stuff, which is also a system of synchronization by stopping working intelligently to keep everything in sync. Theory of constraints is the same. CON-WIP is the same. All flow control mechanisms are basically deciding what and where people should stop working to keep everything synchronized, right? And this means that you should no longer aim to have full utilization of all your resources, and therefore your OEE pressure, the keep every machine working, your overall equipment efficiency, you have to abandon that, right? That's the really difficult thing. I personally believe, in my experience, that in many organizations, not all, but in many organizations, the reason why they're keeping everybody busy is that they're worried about what they're going to do with a person when they stop working, right? Do they ask them just to play with their smartphone? Or do they ask them, what else could you do rather than just drill holes in this piece of steel, right? Could you do something else in the factory? Could you do a bit of maintenance? Could you do some problem solving and so forth? Unfortunately, too often, the reason why people are keeping everybody busy is because they're uncomfortable with the discussions they would have with the teamwork. So the prerequisite is just having the courage to start. And if you want to learn some more, you can attend our in-person training sessions. They're in Paris in French, or you can register for one of our online training courses. They are in English, or ask us for a flash diagnostic, etc., etc., etc. That is it from me. Thank you very much for all of you for being here and listening. Have a nice day. Bye-bye.